because of the nature of what logarithms are, they do have some properties that will come in handy in situations that equations and other places as well. But so they want us to go over here some of those properties that logarithms have. Now, before I get to those, let me again mention, because these will come up, about the powers when you have square roots and that sort of thing. Again, the square root of x can be written as x to the 1/2. If we encounter another root, like the cube root, then what would the cube root be? Yeah, because this is a square root, the index is 2, and that's why that denominator is 2.
So x to the 1/3?
So the cube root of x would be x to the 1/3, yes. And so fourth root would be 1/4, so forth and so on, okay? Just in case those pop up here somewhere or another. All right, but back to these properties of logarithms. Let's start here with the number one property. There's three basic ones, and then we'll kind of use those for some others, or talk about a few other ones. Secondary ones, I guess we might call them, but important ones too. All right, so here's property one. If we have log base A, and let's use of u, plus the log base A of v, it turns out that those two logarithms can be combined into one single logarithm, and it's the logarithm base A of u times v. U times v. So we took two logarithms there and condensed it into one, and we can go the other way with it too, but kind of interesting that, yeah, you got two logarithms added, but to combine them into one, you actually multiply the two things inside there. And just as an example of that, if you look at log base 2 of 4 plus the log base 2 of 8, what this property tells me is that would be equal to the log base 2 of what?
4 times 8.
4 times 8, 32. Is that true? Well, yeah. I mean, that's not really the kind we would be condensing like that, but it shows you that this is true, because what is the log base 2 of 4? Well, that's 2 to what power is 4, right? Changing it back to exponential form, that means 2 to what power is 4, right? What is 2 to what power gives me 4? 2, isn't it? So this is 2. Log base 2 of 8, that's 2 to what power is 8? 3, right? Third power. So that value would be 3. So that's 2 plus 3, and then look at this. 2 to what power gives me 32? Well, 2 to the 4th is 16, 2 to the 5th is 32, so this is 5. Yeah, that's true, isn't it? 2 plus 3 does give you 5, and so that's just how these logarithms work. To condense logarithm A of u plus logarithm A of v, so these have to be the same bases, but if they are, then you can condense them into one by multiplying the u times the v, whatever u times v is. All right? Similarly, log base A of u minus the log base A of v. Well, what do you think? If log base A of u plus log base A of v is, you multiply u and v, if you subtract these two logarithms, guess what? Yeah, you got log base A of u divided by v. Yes. You take u and you divide by v there to get that result. In that case. And then the third property that I want to mention here now is this: if I have the log n times the log base a of u. And so this, what this one has, this is not two logarithms, it's one logarithm, but there's a number in front. Well, to kind of condense that, if you will, turns out that n can be brought inside to make this just a log base a, so I'm bringing this n inside here. And it turns out, if I do that, that n goes inside, but it goes inside not times the u, but to the power, it makes the power of u, u to the n, u to the nth power. I guess a quick example of that. Let's see. Let's have 3 times the log base 2 of, let's just do 4. Make a simple one there. But that says by this property that that should equal the log base 2 of 4 to the third, which is 64. Right?
Yes.
So let's see if that works. That would be here, 3 times log base 2 of 4 is 2. What's log base 2 of 64? 2 to what power gives me 64? Well, again, 2 to the 5th is 32. 2 to the 6th is 64. So this log base 2 of 64 is 6. Look at that. That works, doesn't it? This is 3 times 2, and that's 6. So that's the way it works, okay? So some simple examples of those that work, and we'll, of course, have more complicated ones, I guess you might call it, but shows you that that's the way they work, okay, because of what logarithms are. All right? We'll kind of add, I guess, some to that, secondary ones, important ones, but let's work with these 3 here just a little bit. All right, so one way we can approach these is, like I said, if I look at them taking the left to the right side, that's condensing it, because I'm taking 2 logarithms, basically, the first 2, and making them 1, and like I said, this one's condensing it because it's putting that in inside there. So yeah, let's condense, first of all, some logarithms. And what we're going to mean by that is condense them into a single logarithm. That's what we're going to mean by condense. So you're going to have multiple logarithms, so we're going to condense them into one. Okay? All right, so number 1 on this. So let's take the log base 2 of x plus 4 log base 2 of 5. So this has 2 logarithms added. Now the problem with these 2 logarithms added is because it's not quite in the proper form for property number 1, because it says log base a plus log base a. This is log base 2 plus 4 times log base 2. And so before I can use property 1, you see I'm going to have to use property 3 first, all right, to get it into property 1 format there. So this is my property 3. This 4 needs to go inside. Well, it doesn't go inside times the 5. Where does it go? It goes inside and becomes a power. Power on that number in there.
Which equals 625.
5 to the 4th is 625. Okay. So we got log base 2 of x plus log base 2 of 625. And so now we can use that property 1. And by property 1, I can combine those into a single logarithm. And it's not the 2 added, you multiply the 2 on the inside, don't you? So it'd be x times 625, or probably more appropriately, it'd be log base 2 of 625 times x. So see what we did there? We took two logarithms and condensed it into one. That's the idea. All right, number 2. Here. How about log base 3 of x plus 2 minus log base 3 of x minus 2 Well, that's actually a pretty simple one because it's already in the appropriate format. Which property can I use there? Number 2, right? By property 2, this can be condensed into one logarithm, be log base 3, one single logarithm, and it would be u divided by v since the two logarithms are subtracted. So I'd take my u and divide it by v, so it'd be x plus 2 divided by x minus 2. And you can put parentheses around that if you want to make sure it's understood there. Okay? So that one's just pretty well direct there. Now what if I have 3 of them? What if I have log base 4 of x plus log base 4 of x minus 1 minus log base 4 of x minus 3? Well, two at a time if you want to step by step it, but these two, well, those are property 1, right? I've got two logarithms added together, and so those would condense down to one logarithm where there's times. So yeah, those two would combine into one. Where you have x times x minus 1. And then you want to all at once, but then with the minus, that then on the end there, that's property 2, isn't it? So these are then going to be divided by that one, right? So it'd be one logarithm, logarithm base 4, x times x minus 1, divided by the third one, x minus 3. Yes? So we took 3 logarithms into one. Right there. All right. A couple more here.
Would it have been okay to distribute that x on the top?
Could distribute the x there on top, yes. Make it x squared minus x, sure. All right, here's the fourth one. All right, so 2 ln of x minus 7 ln of y plus 8 ln z. Similar to number 3, but what's the difference here? There's a first step on this one now that we have to take that we didn't have to on number 3.
You have to distribute the 7.
Yeah, the 2, the 7, and the 8 are kind of in the way, if you will, because to use property 1 and 2, you can't have numbers in front of the logs. And so those numbers in front need to be taken inside, but they don't go inside as times, they go inside as powers, right? So this would be ln of x squared minus ln y to the 7th plus ln z to the 8th. That's how those work. So then, like I said, go 2 by 2. These two, all right, so these are, we hadn't mentioned it, I don't think they give you anywhere. You don't have the same base logarithm, but this only works if they're all the same base, right? They got to be the same base throughout. And these are all base E, so they are all the same. So we can condense them. These are subtracted, so it'd be x squared divided by y to the 7th, ln. And then those two, you got plus then ln plus an ln, so those would be times x squared y to the 7th times z to the 8th, or since that's z to the 8th over 1, we could say just ln x squared times z to the 8th over y to the 7th. Either one of those would be okay. So it's okay? Problem, concern? All right. One more of these, and then we'll go the other way. What about 1/2 log a plus 2 minus 1/3 log of a minus 4? Same deal as number 4. We've got these numbers in front, and so those numbers in front need to be moved inside. And if we move them inside by property 3, they become the powers on our inside stuff. So it'd be log a plus 2 to the 1/2 minus log a minus 4 to the 1/3 power, right? 1/2 power and 1/3 power if I move those in. All right, well that brings up the point that we first talked about, and that was, what is the 1/2 power? Because they probably wouldn't leave it. Is it wrong to leave it that way? No, but they would probably not want us to leave it that way, because what is 1/2 power? Kind of in a more common format there. What is that? 1/2 power? That's the square root, isn't it? Yeah, so this is log of the square root of a plus 2. And then this is the 1/3 power, and so that would be the cube root. Cube root of a minus 4. That's probably how they would show that answer. Oh, oops. Got one more step though, don't I? One more step, because we're condensing. Then I can condense them into one logarithm, and it's subtracted. So what happens? You divide the inside parts. So it'll be log of the square root of a plus 2 divided by the cube root of a minus 4. And that would be our final answer there. All right? Okay, now, like I said, there's some secondary, those are the key ones, but these others are important because we'll utilize them in different circumstances. So here's a couple other simplifying ones. Better do the other way first before I talk about those. The other way, we can go the other way with this, and that is expand. And what we mean by that is expand it into simpler logarithms. And what that basically means is we're going to go the other way. So instead of taking these and make them 1, we're going to take 1 and make them 2 or more logarithms, you know what I'm saying? So if I have a logarithm that's times, two things times together, multiplied together, then I'm going to break those up into 2. And same thing there. And then this one, I can bring out the power. That's probably the way that we utilize these the most. But anyway, let's look at a couple of those on that way. Yeah, so expand, number 1, log base 6, 7x squared. So I want to expand that. And what that basically means is expand it into 2 or more simpler logarithms, okay? Expand it into 2 or more simpler logarithms. All right, so what do we see here? Well, I've got 7 times x squared, and so that can be expanded by property 1 into 2 logarithms that are added together. So this would become the log base 6 of 7 plus the log base 6 of x squared. Because those are times together. So That's property 1 kind of in reverse of what we were just doing. Yes? And to be officially totally expanded here, by property 3, what can I do here?
2 times log.
I can bring the power out, and it becomes,
2x.
yeah, a number in front there. So it'd be log base 6 of 7 plus 2 times log base 6 of x. So that's, by expand, that's what we do. Number 2 here, log base 3, 4x cubed divided by square root of y. So I want to expand that into simpler logarithms. Well, hopefully there you see times and divide. So I've got 4 times x cubed, and then I've got divide by square root of y. And so by property 1 and 2 here, couldn't I expand that to be the log base 3 of 4 plus the log base 3 of x cubed minus the log base 3 of the square root of y? Is that okay to do that all at one whack there? I've got times and I've got divide. And so by property 1 and 2, I can do this.
Does it matter which way you do it?
Does it matter?
Like if you choose to do the minus or the plus first or after, does that matter?
As long as this one's minus, you know, you've got minus log base 3 of square root of y.
I think she's asking
do
if you
it.
could, you know, get the division out first and then.
You get the, yeah, you can do the division and then expand it. I just did it all at once, yeah. Yeah, so then it's just property 3 here. The cube can be popped out there. So it'd be 3 times log base 3 of x. This one also, because like we said, that's y to the 1/2. So what would that be?
1/2 log 3 of y.
1/2 log base 3 of y, yes. Okay? Good with that? One more, so, and it's similar to that one. Log base 8 of x squared y to the 5th divided by cube root of z minus 1. Yeah, so on that one, same deal, but it has one other component to it that I wanted to mention. And that is this: if I expand it out, same deal. Log base 8 of x squared, log base 8 of y to the 5th, minus log base 8 of the cube root of z minus 1, right? Because that's pretty much the same. I've got times and I've got divide, so those would be separated there. Okay. Now, power comes out. That pops out, that one pops out, so it'd be 2 log base 8 of x plus 5 log base 8 of y. And then this would be z minus 1 to the 1/3 power. Cube root is 1/3 power. And so that would be minus 1/3 log base 8 of z minus 1. So it's pretty much the same deal. However, what I wanted to mention here is you might be tempted to be thinking, well, that's z minus 1. Does that expand? Can I expand that? And the answer is no. You cannot expand that right there. The log base a of u minus v, that's not equal to the log base a of u minus log base a of v. That's just as far as you can take it. The only thing you can expand is times, divide, and the u to the power. So U minus V or U plus V, same idea. You can't expand those, okay? So that's as far as that goes, okay? With me there?